Today you're going to be using that graph paper and the graphing grids you have set up because we're going to be looking at graphing still. Of course, we just took our Unit 1 test where you did a bunch of graphing. You're going to be continuing to use those same graphing skills here in this unit. And so what we're going to be looking at is first of all, how we can solve a system of equations like this. Now, first of all, a little bit of terminology. Why am I calling it a system of equations? You notice the curly brackets next to it. Whenever you see those curly brackets next to a couple equations, it's saying that these equations are related to each other. The x's in one mean the same thing as in the other. Same thing for the y's. They're talking about the same stuff. And so we often want to be able to solve those. Now when we talk about solving them, we're trying to basically just figure out at what point they're the same. Well, I'm hearing points. I see a couple linear equations. So my mind goes to graphing. And that's the method that we're going to be taking a look at and working through today, is where you are going to graph the system of equations in order to solve it. Now, when we use graphing in order to solve a system, basically what we're going to do is we are going to graph each of our two equations on the same graphing grid, and then we're just going to look and see where they are the same. So, do you remember how to graph this first one? I hope so, because this was in the last unit, right? And do you remember how to graph the second one? Yeah. Again, I hope so. In fact, that's the one that's kind of the oldest and most familiar of them. So, please do so. Please graph both of those equations on your first graphing grid. So for that first one, we're in point-slope form. Remember, point-slope form, I can look at the numbers and it tells me a point. Specifically, the number that's over here at the y, that's moving in the y direction. That's going to be moving it up and down. Now, since it is over on the same side with y, remember that means it's going in the opposite direction. So minus is actually going to be going up 7. Just like when I have a number in with x, it goes in the opposite direction from what you might think as well there. So minus 4 goes to the right 4. And so that's how you're getting to your first point. You're going right 4, up 7, and then use your slope as normal. Our slope here is 3, so that means up 3 and over 1. You can go ahead and plot those points in. Yes, we want to be as accurate as we can with these points. And the further apart they are when we lay down the ruler or rather straight edge, the more accurate we're going to tend to be when we actually draw that line in. But yes, make sure you're using a straight edge here. Accuracy is going to be a big deal. All right, and then for the second equation, y equals 2x minus 4. The one mistake I tend to see, if anything, on this is that I'll see people mixing up what the 4 does. Well, to help you see that, notice there's no parentheses around the x minus 4. The lack of parentheses there tells me that the 4 is not moving it over. The 4 instead is moving it up and down. Now, in this case, since our up and down is on this side, it's not over with the y, but rather on the other side. That means minus is still going to go down. So this one goes down 4 and only down 4. It's not having to go over 1 or anything like that. It's just down 4. And then use your slope as normal again from there. So slope of 2 is up 2 over 1. Again, plot the points out as you go. It's going to help us be accurate with these lines. And then grab the straight edge, draw the line through it. Now, accuracy matters a great deal here because we are going to get our answer by looking at the graph. We are specifically looking to see where the two lines intersect. So we're looking for that point right there. You're giving it as a coordinate pair. Remember, x then y, over then up. So it's going over 1, and it's going down 2. So that's our final answer. That's what we were looking for this whole time. We were just looking to boil it down to an answer of 1, negative 2. Our graph, that was just our work. Just like we might show algebra steps, we're showing our work through the graph in this case. Use what we just did on the last problem, apply the same process now to deal with this. And yes, they aren't both lines, but the same methods will still work. All right, so for our first equation, the first thing we do is we move it. The minus 3 is the only addition or subtraction, so that's our only movement. That is specifically moving it down 3. Once I have that, then it's just down to the slope of 1/3, which means from that point, I'm going to go up 1, right 3, and just follow that pattern along, or I'm going to go down 1 and left 3 on the other side. And I can keep extending that pattern out in order to be able to draw the line nice, neat, and accurate. Then we hit our absolute value function. Now when we're graphing absolute value, remember anytime you see these 2 bars, that means that we're going to have a graph that's a V shape every single time. That's what the absolute value bars are telling us. It's the shape of the graph. So then the x minus 2, well, the minus 2 is in with x, of course, and minus always moves it to the right. The minus 5 hanging on the end. Well, notice that the minus 5 is on the right side here, not on the left side. When it's on the right side, it behaves like you might hope that it would. So a minus 5, it is moving it up and down, but minus actually does move it down. And I know that because it's not on the same side with y. Only point slope is the one that you're going to see with a number over on the side with y. Otherwise, it's always going to be on the opposite side from y, and it's always going to be intuitive in terms of like minus will move down and plus would move up. And that's a general rule that's going to apply to all the different types of graphs that we see in here. All right, so I put my first point, right 2, down 5. And then I need to know where I'm going from there. Okay? Well, in this case, I know I'm going to have to be going like up and over somewhere, right? How far up and how far over am I going to go on the right? It is going to be up 1 and over 1. Yes. Now, oftentimes we got a question mark with that. We're like, 1? How do we know that that's what it is then? Yeah. Since there's nothing written out in front of the absolute value, it means that there's like that inherent 1. Well, and the 1 works like a slope of 1, which means that I'm going to go up 1 over 1, up 1 over 1, and so on, right? But that's on the right-hand side. On the left-hand side, I'm still going to go up 1 and over 1. Do I have a slope of 1 here? Not quite. What is the slope over here on the left side?
Negative 1, 1.
That's negative 1, yeah. And so when we're dealing with just lines, like this first one that we did up here, we talked about slope because any point that you look at on that graph, it's going to be following that same slope. It's always going to be going up and over the same amounts. But when we deal with absolute value, we start hitting a little bit of a gray area. Because on the right side, that 1 is the slope. And we could talk about what the slope is for that portion of the graph. But on the left side, that slope changed. So the entire graph does not have the same slope. The slope actually changes during the graph. And so we just have to be aware of that and aware of the fact that it does change as we go. And that's going to be particularly relevant as we start getting further along, because it won't be too far down the road and we're going to be looking at curves and how does the number out in front affect the curve and some things like that. And so we'll be talking a little bit about some of that today in terms of the absolute values, but realize that a lot of these same rules are actually being extended into curve territory. All right, so back to our graph here. I would grab a straight edge, draw the graph through there, and you notice that I have 2 points where they're the same. 2 points where they're intersecting. I need to give as my answer both of those points. And so I'm just going to go left, right. There's nothing particular that says I need to list one before the other one. I'm just going to go ahead and choose to do it that way. So my first point here, that's over at 0, negative 2. And then to separate my 2 points, my 2 answers, I'm just going to put a column between them. And then I grab the other point. And that's at, oh, that is negative 3. Thank you. Yes, that's not 0, negative 2. That's 0, negative 3. Thank you very much. Okay, so 0, negative 3. All right, and then back to my other point there on the right side, that's at 6, negative 1. All right, and so we just list those 2 points out like that, and that would then be our final answer. right, next up, we're going to solve this system by graphing, which, yes, of course, does mean you need to remember how to graph from standard form. Those same skills that we emphasized in the last unit, yes, they are going to keep coming back. So let's see how well you remember it. Go ahead and graph both of these on the same set of axes and get your solution. I'm going to start by just checking in on the first one, then I'll give you a little bit more to finish that second graph. But for that first one, you should be going left 1, down 8 for your first point, your vertex. And from there, again, there's nothing multiplied out front of our absolute value, so it's going to be over 1, up 1 on both sides in order to then get your graph from there. When you next go and start graphing from standard form, remember that our technique there is to find the x-intercept and the y-intercept. That's where we plug 0 in and plug 0 in, remember? All right, so like for that first one, where I'm going to try to figure out the point where the y is 0, I'm literally plugging 0 in for y, so it's going to be 3x minus 2 times 0. Well, 2 times 0, of course, is 0. So that just goes away, and so I'm left with 3x equals 18. Therefore, x equals 6. And we now know that point at 6, 0. Then we repeat the process for the second one, where we're looking to see what happens if I plug 0 in for x. Well, that means that whole x term went away, and I'm left with negative 2y equals 18. Therefore, y equals negative 9. And so to make my second graph here, really all I have to do is plot these 2 points. The trick, of course, is remembering they are 2 separate points, not 1 point. And so I go to 6, 0, and 0, negative 9. And then I break out the straight edge to draw. Now, one little side note here. I know some people figure it's okay to get by without actually maybe using a straight edge to draw their graphs, or something that, you guys don't have this problem, but some people have problems with actually using graph paper, and they're like trying to make line paper work. And I get to see this all the time as I walk around and look at people's work and try to give pointers. So let me try to show you what it looks like when you aren't careful. Are you going to be able to tell where the solution is on this graph?
Yeah. No.
You might come up with a guess, but I'm betting that it's really a guess. Even if it looks like we know what we think it is, odds are we're kind of iffy there. So that's why you really do need to take your time and be careful. Compare this kind of free-handed thing with what it looks like when we're really careful. This I can just look at and I can know exactly where that point is. And so that's why I'm always encouraging precision, care. Actually make sure that you're actually taking your time with it. And so I can just look on my graph here and I can see that my answer is going to be at 4, negative 3. And we're done. So last unit, we were just making the graphs to represent the equations. Now, we're using the graphs as a tool to actually find a solution. All right, now I'm going to start talking through these. I'm going to go through the first one, and then I'll give you a little bit more time to finish that second one if you're not quite done with it. Because if you can do the first one, then I don't think that second one's going to throw you off anymore. So for the first one, the first thing we do is just need to know how far do we move it over and up and down. That part, nothing has changed. I know some of you are looking at this too and thinking, what's it doing to it? It does not change how we get to our vertex. So the minus 1 on the inside, it's still going to go right 1. I do not multiply it by the 2. The minus 5 hanging on the end, it still goes down 5. So I go right 1, down 5, plot the dot. That's our vertex, same as always. Notice we haven't touched the 2 yet. The 2 is being multiplied by it. And just like when we deal with a line, for instance, if I gave you the equation y equals 2x minus 5, the 2 would be your slope. This is going to work much the same way. And so I'm going to be going up 2 and over 1. Now on the right side, I'm going up 2 and over 1, right? On the left side then, what's going to end up happening? Well, it's also going to be up 2 and over 1. It's just going over the other direction. And so you plot each of those points using that 2. Now, I want to kind of bring you back to something here. I'm going to take a little bit of an aside from finishing out this problem and talk about what that 2 is really doing, because I'm going to talk about it in a way that's going to help us to connect it to what we're doing later as well. The normal graph for absolute value is going over 1, up 1 on both sides. If I take a look at those points there, so like normally it's going over 1, up 1, notice where the height of that point is, where they're just up there. In this case, notice that that line that connects those 2 points has been moved up. It's like I physically am grabbing that green bar and pulling it upwards twice as high. The same thing is happening to every pair of points. So like if I look at these points here on the original absolute value graph, if I grab that bar and pull it up, it ends up here. Again, literally twice as high from the vertex as the original. That's what that 2 is doing. In fact, that's what it's always done. Even when you've been graphing just lines, and we change our line from going like that to going like this, what we're really doing is we are actually vertically stretching this graph. We're taking a point that was just up 1 and we're going up twice as far. That's all slope ever has actually been. Slope has just been the particular line form of a vertical stretch. And if you remember that, then when we get down to seeing how this is all going to look when I give you like a parabola or something like that, you're going to be able to handle the way that it happens with a curve much easier. Because if you're locked into just thinking about slope, you don't get curves, you get lines. And obviously, if it's not a line, that's going to be a problem. So just kind of keep that in mind as you go. All right, I said I'd give you a moment to finish the last one as well. Before I do, what does the negative do to that graph? Yep, it flips it. Specifically, it flips it upside down. We also will call that a reflection across the x-axis if you want to be fancy, but it flips it upside down. But you'll still start at the same place. So then for the second graph, we're going to be going left 2 and up 4. Again, notice that the negative out front, it did not impact the behavior of what the 2 did. And so then I'm going to put my first point left 2 and up 4. But then instead of going over 1 and up 1, we're going to go over 1 and down 1. And we're going to go ahead and just follow that pattern on both sides. Plot as many points as you can so that you can get a nice, accurate drawing with your straight edge. But then you can go ahead and draw that in to get your final graph. Now remember, the graph itself is just the work. It's not the final answer. It can be very tempting to think of it as the final answer because normally graphs are what we're trying to create, but it's not. So I'm going to grab my 2 points, and again, the order in which you list them does not matter, does not change anything. So in this case, I'm going to say negative 3, 3, and then I'm going to grab the 3, negative 1. So then that's our final answer. Yes, both of those points must be included in that answer.